Alright, in this video, we're going to go over arithmetic versus geometric sequencing. And in this topic, it may seem initially that there's a lot to cover, but it's actually not that, complicated. So let's go over arithmetic first. So when we have arithmetic, we have the first formula, which is a of subscript n equals a of subscript 0 plus dn. Now, what these variables symbolize. Hold on. A of n, that would symbolize the target value of the arithmetic sequence. What a subscript 0 would symbolize is initial value of the sequence. D is the common difference. And n is the nth term that you're solving for. And we'll get into that soon. Then we have another formula, which is a of n equals a of k plus d times n minus k. Now, we know what a of n is, we know what n is, we know what d is. But what a of k is symbolizing is the kth term of the sequence. Wait, no. I mean, it does simplify that, I'm sorry. But what it does simplify is like the number at kth term of that sequence. And then k is the kth term in that sequence. Now, when it comes to geometric, it's a similar idea. We have g of n equals g of 0, which is the initial value. But then we have r, and then to the power of n. Now, what r symbolizes is the common ratio, which is basically behaves like the common difference, but for geometric sequences. And then for the next formula, we have g of n equals g of k times r to the power of n minus k. So what's the difference between these two formulas and the difference between these two formulas? Well, these two formulas are only used if you know the initial value of the sequence. These two values are used if you're only given, like, say, the second term or third term of a sequence, of an arithmetic or a geometric sequence. So let's try a practice problem with arithmetic. So let's say we have a of 2 equals, say, 18. And we know that a of 5 equals 27. But we want to find out what a of, say, 12 equals. Now, you might notice one thing. We don't know what d is. And that's what makes it a little challenging to answer this question, because we need d to solve for a of n. And a of n is the value that we're trying to solve for, which is a of 12 in this case. So to find d, we introduce another formula. And the reason I'm introducing this so early is so that we can get through this pretty quickly, just so there's less confusion later on. So what we have to do is first subtract a of the greater term, which is 5. Subtract a of the lesser term, which is 2, from a of the greater term, which is 5. And then divide that by 5 minus 2, because we were doing 5 minus 2. Because we have the fifth term and the second term, you're basically subtracting the lesser term from the greater term. When you plug in the numbers, you get 27 minus 18 divided by 3. 9 over 3. And you get d equals 3. Interesting. I didn't mean for it to be an integer. But since d equals 3, and I guess since it's an integer, it makes life a lot easier. So now all we have to do is figure out which formula to plug in. And that would be this formula, because we don't know the initial value, and it's just better if we don't. So we don't overcomplicate things, okay? Because we know the kth term, which can be either one of these. It's up to you to choose which one. It doesn't really matter which one you choose. Then we have to set this up. So for me, I'm gonna do a of 2 plus 3 times n minus k. N is 12, k is 2. So that's gonna be 12 minus 2. And when we plug in a of 2, which is 18, now we just have to do the math. We pretty much just have to do algebra here, because we're the only variable we don't know that we're trying to solve for is a of 12. So 12 minus 2 is 10, times 3 is 30, plus 18 is 48. That's supposed to be 12. And that's your answer for arithmetic. Now let's do geometric. So for geometric, let's say we have g of 1 equals 6, g of 3 equals 24, and then let's say we want to find out g of 6. Now, same problem here. We don't know what the common ratio is. So what we have to do is set up this formula. Sort of the same idea as how we formed the formula for d in the arithmetic sequence, but except this one is a bit more complicated. But basically what you have to do here is divide g of the greater term, which is 3, by g of the lesser term, which is 1. So g of 3 divided by g of 1. And then we take the quotient of that and put it to the power of 1 divided by the greater term, which is 3, minus the lesser term, which is 1. So 3 minus 1, which would eventually be 1/2. So let's plug that in. And you probably might need your calculator for this, because this is quite interesting, to say the least. So 24 divided by 6 to the 1/2 power. 24 divided by 6 is 4. And then we just get 2. Because 4 to the 1/2 power is basically asking the square root of 4, which is 2. Well, I actually didn't intend for it to do that, but wow. I'm actually good at making up math problems. Okay, so now what we have to do is find out g of n, and g of n is g of 6, because that's what we're trying to solve for. So what we do, just pick whatever one. I would honestly pick the smaller value for to represent g of k. So 6 times 2 to the power of n minus k. So that would be 6 minus 1, which can simplify to just 5. 2 to the 5th power is 32. 32 times 6. And here's your answer. G of 6 equals 192. And that is how you do arithmetic and geometric sequencing. And the reason I'm making it so hard now is so that you can understand the hard stuff early on. And even if you don't understand them now, you're at least exposed to it and you're familiar with it. So that could really benefit you. So you're not like totally overwhelmed when you're in class. It's honestly better to be overwhelmed in this video than it is to be in class, and especially on the day of the test, because that would really suck, especially if your teacher does not allow quiz retakes. That would really suck if you're spooked on the day of the test. So honestly, if you're freaked by this video, don't blame yourself. It's normal. Math is not an easy subject, so you have to absorb information at your own pace. So I would encourage you to, when you're watching my videos, I would really encourage you to take your time, pay attention to what I'm doing, and just simply absorb the information so you're prepared for what's going to happen in your math class. Okay, that's all I wanted to do for pre-calculus. I will see you all in the next video.